Good day, teacher. In this video, I'm going to explain how we can graph signals of different frequencies and how to find their Fourier transform and graph the result. Previously, I create this file and this folder. We uploaded these files uh, that contain the signals of different frequencies and different forms. Right. The first in the first line we write who is assigned to write the code, and then I'm going to write a comment and scribe by this is my email, and the next part is reset id values, id variables, and console. This I do with TLC and clear command. Then we load the digital sound by assigning the previously loaded file a vector of size gfs and typing the file name in the audio read command. Okay, this is the vector with variable g and fs, and the command audio read and the name of the file that I'm going to evaluate or calculate. For this part, this is all. Next, we establish the configuration of the parameters of the signal. For a initial period, T initial, it's equal to 0. L variable, it's equal size of g. G is the variable that I can see in the vector of audio read. L equal L in the first position, it's the signal size. And this is loading some signal, and this is signal parameter settings. For the final period, T final, it's equal L minus 1 over Fs. Fs is the order value of the principal vector of audio read. This equation is the final time for signal. Right, and the last line of this part of the signal's parameter settings, it's equal a time vector construction. It's t equal vector of 0 to 1 over fs to t final. And this how I said it's final is time vector construction. We proceed to graph the signal obtained from the previously mentioned audio. We title it, and to the components g and x we assign the variable in time of the previous module and the size variable of the first vector of it. We obtain 500 shots to the signal. This section is do it with the function plot. The variables t and g are the parameters or the labels, and this signal going to plot of total signal to 10 seconds. The title is its full signal because we can see the old signal, the original signal. His labels are t in s, t in seconds, and the label g in t. And pause of 10 seconds to with this line we can see the function or the graph during 10 seconds. Now we carry out the fast Fourier transform that is given for vectors. This is possible thanks to FFT. Yeah, it's equal to FFT, the y. This variable is obtained to the first vector. And we going to graph the Fourier transform. It's a same function that the plot of the full signal. The unique difference it's we going to normalize the magnitude of the FFT G over L. This part normalized the magnitude. P1 it's equal to P2 cross 1, 2 L over 2 plus 1. And P1 cross 2, 2 and minus 1 equal 2 cross P1 2 tau and minus 1. Right. This is the Fourier transform normalized the magnitude of the FFT. And the last part is plot if it's the final function in the frequency value. Right. And then I'm going to assign to fs the first variable of the vector of the principal vector. It's equal it's multiplied to 0 to L over 2 over L. Plot f p1 f p1 f p1. The title of this graph is right type J in the value of frequency. In this case we're going to use W. for j in t, in time. G of t. Right. X label, it's assigned with f in hertz and G label, it's named with P1 of f right. This is all. And this part I'm going to erase these things because they don't necessary. Right, I'm going to run the program. And we're going to see the different graphs. Okay, here we save like a project. Right, now we can evaluate three different signals. For the first way, I'm going to use a signal of 10 kilohertz of 16 bit during 30 seconds. It's that signal. And then 10 30 seconds and run the project. Here the program take the first 500 samples of the signal, and this is the form, and this is the right side to omega and frequency. This is the signal, and the next form that we're going to evaluate is pulse. Pulse is a signal that we found on internet. Run. This is the full signal. This is the full signal, and this is the signal pulse. This is the transformation. And this is the transformation function to this signal. And the last one is triangle. And run. Again, the program takes the 500 samples. This is the signal of triangle, and this is the Fourier transformation. This is all of this video. I hope that you enjoyed, and see you later.